Hi everyone, let's take a look at the following function. Y equals to x to the power of x and y equals to x to the power of x to the power of x. The question here is to find the derivative, specifically dy by dx. So this is what we call logarithmic differentiation. So anytime the exponent contains an x, you cannot apply the power rule. So for example, the common mistake that we see is dy by dx equals to x times x to the power of x minus 1. This is not how you find the derivative. So again, logarithmic differentiation. You cannot apply the power rule because the exponent is not a constant. Now, let's start with the first case. Y equals to x to the power of x. So on both sides, what you can do is take the ln of y, which equals to the ln of x to the power of x. Again, what happens is when you think about the properties of a logarithmic function, one of them states that the exponent can be brought to the front. So on the right-hand side, this equals to x times ln of x. Now, we can find the derivative by applying implicit differentiation. So again, our goal is to find dy by dx, and again, this means find the derivative of y with respect to x. On the left-hand side, when you differentiate ln y, that's going to be 1 divided by y times dy by dx. On the right, we're applying the product rule. Again, there are 5 steps when it comes to the product rule. Step number 1, differentiate the first. The derivative of x is going to be 1. Step 2, copy the second part, plus copy the first part, times the derivative of the second part, which is going to be 1 divided by x. So again, 1 divided by x is the derivative of ln x. 1 is the derivative of x. Dy by dx equals to, you can multiply both sides by y. So you can bring y to the right-hand side times, open brackets, ln x plus 1. Now don't forget to express dy by dx only in terms of x. We write the function y in terms of x. So y equals to x to the power of x times ln x plus 1. And we put this in a bracket. Case number 2. What happens when y equals to x to the power of x to the power of x? Same idea. And in the second example, we need the first example to speed up the process. So again, if y equals to x to the power of x to the power of x, step 1, ln both sides. Step number 2. Again, if you think about the right-hand side, you can bring the exponent to the front. And in this case, the exponent is going to be x to the power of x. So again, let's make sure you can see this. This exponent, x to the power of x, is now brought to the front. When you find the derivative, dy by dx, again, you're applying implicit differentiation. On the left, when you find the derivative of ln y, that's going to be 1 divided by y times dy by dx. On the right, you're going to apply the power rule. Here's the first function. Here's the second function. So again, when you find the derivative of x to the power of x, this equals to, and you have to go back to the first example. So we wrote down dy by dx is going to be x to the power of x times ln x plus 1. So we're going to copy this right here. X to the power of x times ln x plus 1 times ln x plus, copy the first part, x to the power of x times the derivative of ln x, which is 1 over x. Now before we bring y to the other side, let's collect like terms. So you copy the left-hand side. On the right, again, you can draw these arrows. X to the power of x times ln x plus x to the power of x in brackets times ln x plus, again, think about this second part, x to the power of x divided by x, which is really x to the power of x divided by x. Again, we can clean this up in a little bit. Let's keep going first. Again, 1 divided by y times dy by dx equals to, let's draw the arrows again, x to the power of x times ln x, which is ln x squared, plus x to the power of x times ln x plus x to the power of x divided by x. Now, I'm going to bring y to the other side. So again, the opposite of dividing by y is to multiply by y. I'm going to copy all this for now. So ln x squared could be written like this as well, plus x to the x ln x plus x to the x divided by x. Now, your goal is to express dy by dx in terms of x. Y is equal to x to the power of x to the power of x. Now, notice there's a common factor here. So if you really look at it, you can factor x to the power of x to the front. So times, I'll put this in brackets, x to the power of x, open another bracket, ln x squared plus ln x plus 1 divided by x. Now if you collect like terms, dy by dx equals to, again, when you multiply the same base, you can add the exponents, x to the x plus x. So again, these exponents are now added times ln x squared plus ln x plus 1 divided by x. Or if you want to factor a little bit more, and again, this depends on the textbook, depends on the teacher sometimes, you can factor 1 divided by x to the front. So remember, if you think about this last part, 1 divided by x is the same as x to the power of negative 1. So if you want to factor a little bit more, you can take out this x to the power of negative 1, which means dy by dx equals to x to the power of x to the power of x plus x minus 1 times, now because you took out x to the power of negative 1, you're attaching this x back into the brackets, just like that. So again, depending on your teacher, you're going to figure out which final answer is more acceptable. I hope this makes sense.